Dr. Reynoso.
And I'm Dr. Memily.
Today we're going to be talking about
balloons and
buoyancy.
Do you guys know what buoyancy is?
No.
Hi guys, today we'll be talking about two different objectives for balloons and buoyancy. One of them is to indicate how gas causes a hot air balloon to rise or fall.
Hello everyone. Another objective we are going to be talking about is how pressure and volume are related.
Hi, as we all know, gravity is something that pushes things down. But when we see a hot air balloon, it always goes up. Now clearly, there is something that is pushing this hot air balloon up, and that is buoyancy. Buoyancy is a force that pushes things up against the will of gravity. The strongness of a density depends on two things, the density of a fluid and the density of the object. The density of the material is simply mass divided by volume.
Volume is a space that a substance can occupy or contain. Now a substance could be a solid, a liquid, or a gas. Hi, so the volume of a container is generally understood to be a capacity of the container or the amount of fluid that the container could hold rather than the amount of space the container itself can display. Now a fluid can be a gas or a liquid. For example, this container is holding a liquid that can be shown to you. So therefore, when you're looking at this container, you see the liquid.
Now that you know how buoyancy works, let me explain to you how this all goes together with my objective. The basis of how a hot air balloon works is that warmer air rises in cooler air. That is because hot air is lighter than cooler air. So, the result is that the air inside the balloon is heated to a high enough temperature that the entire balloon's apparatus as a whole becomes less dense than the surrounding air. And buoyancy wins out gravity, and the balloon rises.
Pressure is the ratio of a force to the area over which the force is being distributed. There are many types of pressures, but one pressure is a pressure of an ideal gas. Now, an ideal gas have molecules that have no volume and do not interact. Pressure varies with temperature, volume, and quantity according to the ideal gas law. Now, the ideal gas law is P equals minus little n, big R, big T, over V. The second objective is how pressure and volume are related. Now, pressure and volume are inversely proportional to each other. Now, if pressure increases, the volume will decrease. Now, that goes for vice versa. Now, if you push gas by decreasing its volume, it pushes back by increasing its pressure. Now, this is called Boyle's law, which makes up the part of an ideal gas. Boyle's law. Boyle's law is PV equals little k, which k is constant. Now, the law states that at a constant temperature for a fixed mass, the absolute pressure and volume of a gas are inversely proportional. Hey, so we're going to be doing an experiment of Boyle's law, and Boyle's law is
Used to explain how pressure and volume relate to a hot air balloon and buoyancy.
yeah. So for this experiment, we're going to have a pan that's heated up. We're going to have an empty can that has to have 3 tablespoons of water. You're going to need a tonsil, but we're using a salad holder. And then you're going to need a big pan, or pot of water with ice.
And you have to wait until it smokes. The can smokes, and it's smoking. And you take this. Yeah. Look.
I don't see it, but okay. So you need to wait into that can. You see a little bit of smoke coming out.
Look. You see it?
All right.
Okay.
We see smoke. So that means you need to turn it over upside down so that the water, 3 tablespoons of water, can go inside that can. I mean the pot. It did! Okay, so we have accomplished this lab, and we're going to show you the results. So this is what should happen. This should happen. You see
The can is now all crumbled up. Before it wasn't. And this is because
the vacuum emptied out. So now we have an empty can and the experiment worked.
Due to pressure and volume.
Yes.
And the temperature of the stove heating the 3 liters of water.
Yes.
And it caused the smoke, causing it to have vacuum. And when hot water hits cold water, that's when all the molecules and particles all add up together to create this.
This would be a perfect experiment for you to see how buoyancy works.
Okay, so here we're going to show you the simulation for balloons and buoyancy, and we're using a hot air balloon. Now, as you can see, we have the pressure, volume, and temperature. Right now, nothing is going on, but when you start pumping into the hot air balloon, you see there's a change. And we're going to also add heat because that's what hot air balloons do. And this is how volume and pressure are going to interact with this experiment.
Now pressure varies with temperature, volume, and quantity according to ideal gas law. Now in the theory, when the volume of gas shrinks, the gas molecules have less space to move around, and so they hit their balloon more often. Now we're going to move on to pressure. The more frequency the gas impacts this container wall or the balloon wall, the higher the pressure. So as volume decreases, the pressure increases. As you can see, they are related. There's no drastic change in this experiment.
There are many types of pressure, but what are you doing?
Hi, I'm Dr. Reynoso.
And this is how the hot air balloon rises up.